Very good afternoon, students. Today is the 21st of June 2021. Now, in this 21st century, you are knowing we are suffering a lot and we are now understanding the importance of our health. So, it is very, very important. Instead of wasting of your time, just you take care of your health and just see the online lecture on the sulfuric acid. We learn many times that sulfuric acid is the king of chemicals. The reason behind it is the dehydrating agent. So wherever the cans are used or we don't want that moisture in food particles or that for keeping it for a longer time, maybe fruits, likewise that apples, the cans which are having that fruit juice or fruit pulps or that medicines. So that time sulfuric acid fumes they are to be used. We are the chemistry peoples and that's what we have to understand why it is to be having that larger amount to given for the students those who are preparing or working in a sulfuric acid industry. This is the very biggest industry that we are knowing that sulfuric acid, that's what the economy which releases from this industry, it is very high, and that's what we have to understand what is the preparation and how it is to be purified in a larger quantity. If we had given the sulfuric acid which is highest in the purity, then we will demand that highest amounts too. So most of the western countries they are demanding a lot of the sulfuric acid from the India, and we are having that much courage that we have to supply the sulfuric acid to them. Let us start according to the industrial view how it is to be prepared. See the slide which I had shown you on the screen, that H2, 2 molecules of hydrogen, 4 molecules of oxygen and 1 sulfur, it is to be there, whereas the sulfuric acid to be formed. So the structure of sulfuric acid, it is to be there, which is of having that OH bond, and the oxygen which is to be having the double bonded. See now the sentence which is to be written, there was a girl who is no more, for what she thought was H2O was H2SO4. The uses of sulfuric acid. Manufacture of plastic atoms, rayon, nylon. So this is the biggest industry we are knowing. So the clothing industry, there it is that it is used the sulfuric acid as an important chemical. Manufacture of paints. Most of the paints we don't want that water or that moisture in it, and that's what that paints it is also used the sulfuric acid fumes. Manufacture of pesticides. Most of pesticides they are to be using that sulfuric acid. Manufacture of fertilizer where the sulfur it is to be there. For example, ammonium sulfate. Manufacture of electrolytes, that is car batteries, we are knowing that the water which is to be there, it is the dehydrating or drying purposes they are using that H2SO4. And manufacture of soaps and the detergents. This is the next top highest industry and it is growing up and up, and that's what sulfuric acid importance it also increases or raises much. So steps of the contact process. Remember this, that for the industry chemistry in heavy chemicals, we are having the two chemicals. One is the H2SO4 that is king of chemical, and second it is the ammonia by Haber process. So these two processes they are asked in the examination for many times, and that's what we have to understand each and every point how it is to be prepared. So today we are studying the contact process which is of a sulfuric acid. Now the name of contact process it is to be given for the H2SO4 preparation because sulfur and oxygen they come in contact, okay, and therefore there is the formation of a sulfur dioxide. This sulfur dioxide when it will come in contact naturally, so that's what the process the name it is to be given for the contact process. First step, the combustion of sulfur makes sulfur dioxide. That is very important. So when sulfur it is to be combusted with the oxygen air, aeric oxygen, you can see there is the formation of a gas sulfur dioxide. So one, that sulfur 8, when it is to be combined with the 8 oxygen molecule, there is the formation of 8 sulfur dioxide. The second step, that sulfur dioxide is converted into sulfur trioxide. The reversible reaction at the heart of the process, and this is very important process. So when sulfur dioxide prepared, then again it come in contact with the oxygen and there is the formation of a sulfur trioxide. This sulfur trioxide, it is very important, is converted into concentrated sulfuric acid. First of all, there is the formation of oleum, that is H2SO4 in liquid state. When sulfur trioxide it come in contact, there is the formation of H2S2O7, that is in a liquid state, oleum, and again it will contact with the water, there is the formation of a liquid H2SO4. So this second step, where sulfur trioxide it is to be prepared, this is very important, and that's what the process it is to be having that importance of itself. Called contact, since the molecules of the gases oxygen and the sulfur dioxide are in contact with the surface of the solid catalyst vanadium pentoxide in industry, and that's what the name it is to be placed. Now this is the slide which that shown that making the sulfur dioxide. This can be made by burning sulfur in an excess of air. So the sulfur, when it is to be burned, there is the oxygen and there is the formation of a sulfur dioxide, or by heating sulfur ores like pyrites in excess of air. That is also one of the method. See now the pyrites, that 4FeS2 solid, that 11O2, when it come in contact and it is to be heated, there is the formation of a Ap2O3, that is solid, and the sulfur dioxide gas. Second step, converting the sulfur dioxide into sulfur trioxide. So this is the reversible reaction again, and the formation of the sulfur trioxide is a exothermic, where that heat it is to be exerted. So two molecules of sulfur dioxide in a gaseous state, when it combines with the oxygen molecule, there is the formation of a sulfur trioxide by exerting the heat. Converting the sulfur dioxide into sulfur trioxide. This is the flow chart which is to be shown to you. That is the flow scheme for this part of the process looks like this. That sulfur dioxide plus oxygen from the air, that is into the 1:1 proportion by the volume, and when it is to be heated with the 400 to 450 degrees centigrade, 1 to 2 atmospheric pressure by using the vanadium pentoxide catalyst. This is catalyst used for this, that it will give the much more importance and much more amount of the sulfur trioxide very easily in a very short of time, and we can get after that one oleum and then H2SO4 in a very pure condition. So this is it, the flow chart, which gives that the importance of it. The reason for all these conditions will be explored in detail further in this presentation. Let us see. So the converting the sulfur trioxide into sulfuric acid, it is a toxic chemical. This could be done by simply adding water into sulfur trioxide, but done this way, the reaction is so uncontrollable that it creates a fog of sulfuric acid. Instead, the sulfur trioxide is first dissolved in a concentrated sulfuric acid. There is the liquid oleum which is to be formed. The product is known as fuming sulfuric acid. This can be reacted safely with the water to produce concentrated sulfuric acid, twice as much as you originally used to make the fuming sulfuric acid. So this is the reaction, liquid sulfuric acid, when again it is to be reacted with the water in a liquid state, there is the formation of a sulfuric acid. The proportions of sulfur dioxide and the oxygen. The mixture of sulfur dioxide and oxygen going into the reactor in an equal proportion, that is 1:1. That is an excess of oxygen relative to the proportion demanded by the equation. So the sulfur dioxide plus oxygen, that it is the reversible reaction, sulfur trioxide it is to be formed, and the heat it is to be exerted, that is minus 196 kilojoule. The proportion of sulfur dioxide and the oxygen. The sulfur dioxide to molecule gases in a state plus oxygen in a gaseous state. It is reversible reaction. There is the formation of a sulfur dioxide in a gaseous state.